This incident involving a forklift and a motorcyclist represents a systemic breakdown in site safety management and operational discipline rather than an isolated mishap. The critical failure was the operator's decision to travel with elevated forks, violating the low and close principle, which mandates keeping forks 6–8 inches off the ground to ensure stability and visibility. By reversing without a spotter in a shared use area, the operator relied on a dangerous assumption that the path was clear, failing to account for severe blind spots created by parked vehicles. This lack of perimeter isolation allowed the motorcyclist to unknowingly enter a high-risk zone where the extended forks were effectively invisible. These lapses highlight an urgent need for strict site isolation using barricades and the mandatory use of spotters for reversing heavy machinery to ensure public protection. Rotating equipment poses a severe risk of entanglement due to high-speed shafts and gears that generate overwhelming frictional force. Human reaction times are simply too slow to counter these mechanical forces, meaning that once contact occurs, the equipment can draw a person into dangerous nip points in milliseconds. These incidents usually result from a convergence of systemic failures, including missing machine guards, violations of lockout-tagout LOTO protocols, and the use of improper attire near active machinery. To mitigate these hazards, organizations must adopt a safety-by-design approach, ensuring all rotating parts are enclosed and equipped with safety interlocks. Furthermore, fostering a stop-and-think culture is essential, where personnel proactively identify energy sources before interaction. Ultimately, industrial machinery operates without regard for human safety. Therefore, rigid procedural discipline and physical barriers remain the only reliable safeguards to prevent life-altering workplace incidents. Hazardous work environments demand strict adherence to safety protocols, particularly concerning ignition sources. When a small spark can trigger a significant incident, it signals the presence of a hazardous atmosphere, a dangerous buildup of flammable vapors or combustible dust often invisible to personnel. Such incidents frequently result from failures in ignition control, where the presence of lighters or matches violates safety policies. Complacency and habit often lead individuals to overlook these volatile risks, underscoring the vital need for specialized training. Once fuel, oxygen, and an ignition source converge, fire propagation is nearly instantaneous, far outpacing human reaction time. To mitigate these risks, facilities must enforce absolute ignition control, conduct rigorous atmospheric monitoring, and optimize ventilation systems to disperse combustible concentrations, ensuring safe operations. This incident serves as a critical case study on infrastructure integrity and the domino effect in workplace safety. The root cause lies in structural failure, where heavy-duty hinges suffer from oxidation and metal fatigue, leading to a loss of mechanical stability. Once the upper hinge fails, the center of gravity shifts, forcing the gate downward with high-impact velocity that exceeds human reaction time. The absence of safety interlocks or secondary retention means that there is no fail-safe to prevent collapse. Systemically, the normalization of deviance leads to overlooking subtle warning signs, while gaps in preventive maintenance allow degraded components to go unnoticed. To mitigate these risks, organizations must implement engineering controls like secondary restraint systems and travel limiters, alongside administrative controls such as standardized visual inspections and rigorous clearance testing. Ultimately, adopting a proactive failure mode and effects analysis mindset is essential to treat all heavy infrastructure as a potential hazard.